December 15, 1943. The sprawling Ford Willow Run bomber plant outside Detroit, Michigan, stood as a testament to American industrial might. Fresh snow blanketed the ground outside as Professor Takeo Yoshida and 4 other Japanese scientists were escorted through the cavernous facility, their faces carefully composed to hide their growing astonishment. As representatives of a technical exchange mission approved through diplomatic channels before hostilities began, they had expected to witness advanced manufacturing. What they saw instead would fundamentally alter their understanding of what their nation was truly facing in this global confrontation. You will see one complete B-24 Liberator bomber roll off this assembly line every 60 minutes, explained the facility director, Charles Montgomery, with unmistakable pride. We call it the Grand Canyon of the mechanized world. The Japanese delegation exchanged subtle glances, knowing that their most efficient aircraft factories required 2 weeks to produce a single comparable aircraft. Little did they realize that this facility would be merely the first shock in a cascade of revelations that would shatter their most fundamental beliefs about the nature of industrial warfare. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how a small group of Japanese scientists and engineers came face to face with the unstoppable force of American production capacity, and how their subsequent report, buried by military authorities, revealed the mathematical certainty of Japan's defeat long before the final battles were fought. Professor Yoshida adjusted his wire-rimmed glasses and made another notation in his leather-bound journal. His credentials as a production engineer from Tokyo Imperial University had secured him a position on this unprecedented mission. Alongside him stood Dr. Hiroshi Tanaka, a metallurgist, Kenji Watanabe, a petroleum chemist, Colonel Shigeru Nakamura, an aircraft design specialist, and Lieutenant Commander Ichiro Yamamoto, a naval engineering officer. Their official purpose was to observe American industrial methods as part of an educational exchange, a pretense that had somehow survived the diplomatic rupture between the nations. "The building you are standing in," continued Montgomery, gesturing to the vaulted ceiling far above, "covers nearly 4 million square feet. We employ over 42,000 workers across 3 shifts, operating 24 hours a day, 7 days a week." He paused before adding, "This is just one of 5 major bomber production facilities currently operating at full capacity." Colonel Nakamura, the most military-minded of the delegation, struggled to maintain his professional demeanor. In his experience, aircraft production was a meticulous, almost artisanal process requiring highly skilled workers. Yet here, he watched as hundreds of seemingly ordinary civilians, many of them women, assembled complex components with extraordinary speed and precision. "Our production system employs what we call the assembly line method," explained Montgomery. "Each worker performs only specific tasks repeatedly, becoming highly efficient at that particular operation. The partially assembled aircraft moves from station to station." He pointed toward a massive line where the bomber fuselages progressed steadily forward, from raw aluminum to completed bomber in precisely constructed stages. "Most impressive," commented Nakamura politely, while mentally calculating how this system multiplied output compared to Japanese methods. "May I ask how many of your workers have advanced technical education?" Montgomery smiled. "Very few, Colonel. Most had never seen the inside of an airplane before the war. Many were automobile factory workers, farmers, or housewives just months ago. We've developed a training system that allows us to bring them up to speed within 2 weeks." This revelation particularly disturbed Lieutenant Commander Yamamoto, who knew that in Japan's aircraft factories, many positions required apprenticeships lasting years. The social implications were equally jarring. Japanese military production relied heavily on traditional hierarchies and skilled male workers. Here, women in coveralls operated complex machinery with apparent expertise. The delegation was then escorted to the materials receiving area, where Montgomery outlined another fundamental difference in approach. "Each Liberator contains nearly 1.2 million parts," he explained, "but we don't manufacture most components here. Instead, we've created a network of over 1,800 suppliers across 31 states. Small factories produce standardized parts to exact specifications, which arrive here ready for assembly. Dr. Tanaka, the metallurgist, inquired about quality control with such a distributed system. An excellent question, Montgomery replied. We've developed statistical quality control methods that allow us to maintain consistent standards across thousands of suppliers. Random sampling and testing ensures parts arriving here meet specifications. The result is standardization on a scale never before achieved. The American guided them to a vast storage area where enormous quantities of aluminum sheet, steel tubing, rubber, fabric, and glass components were organized in a complex arrangement. We maintain a 3-week supply of all essential materials, Montgomery noted. Our logistical system ensures continuous production despite any temporary disruptions. First, you see, so what Montgomery diplomatically avoided mentioning was that many of these materials came from seemingly limitless domestic sources. Aluminum from massive smelters powered by American hydroelectric projects, rubber synthesized in chemical plants to replace restricted natural supplies, and high-grade aviation fuel from the nation's abundant oil fields. The Japanese scientists, however, recognized the implications immediately. Their island nation relied heavily on imported raw materials, particularly oil, rubber, and metal ores, resources increasingly targeted by American naval operations. Professor Yoshida, thinking of Japan's strict material rationing, asked how civilian consumption had been affected by such enormous military production. Well, we have rationing of certain items, rubber, gasoline, some metals, Montgomery acknowledged. But our agricultural and manufacturing capacity has actually expanded during wartime. Civilian food supplies remain abundant, and while new automobiles aren't being produced, most families still maintain their private vehicles. This casual comment perhaps struck deepest. In Japan, civilian consumption had been drastically reduced, with metal household items, even cooking pots, being requisitioned for military use. The contrast could not have been more stark. After touring the Willow Run facility, the delegation was escorted to the nearby Ford River Rouge complex, an even more massive industrial installation encompassing 93 buildings spread across 1,500 acres. Here, raw materials entered one end of the facility and completed vehicles emerged from the other, a level of vertical integration that seemed almost fantastical to the visitors. James Wilson, the facility manager, explained how the complex had rapidly converted from civilian automobile production to military vehicles. Before the conflict, we produced passenger cars. Within 6 months, we retooled entirely for war production. Today, we manufacture jeeps, tanks, armored cars, and aircraft components. Our monthly output exceeds 15,000 vehicles. That evening, in their closely monitored accommodations, the 5 Japanese delegates compared notes in hushed tones, speaking their native language, which they believed their American hosts could not understand. What we've seen today represents merely one complex in one industrial region, murmured Professor Yoshida. The total production capacity must be... His voice trailed off as he calculated figures that seemed too enormous to speak aloud. Colonel Nakamura nodded grimly. The aircraft plant alone produces more bombers each month than our 5 largest facilities combined, and their bombers are heavier, with greater range and payload capacity. Lieutenant Commander Yamamoto, whose expertise was in naval engineering, added his perspective. Their shipbuilding capacity follows similar principles. Reports indicate their new Liberty ships are being completed in average times of 42 days, with some finished in less than 5 days. Their aircraft carriers, destroyers, and submarines are being launched at rates we cannot possibly match. The implications hung heavily in the air between them. Japan had initiated the conflict believing in qualitative advantages, superior training, fighting spirit, and initial technological edges in certain weapons categories. But the quantitative reality becoming apparent to these experts suggested something entirely different. "We must be thorough in our observations," Professor Yoshida finally said. "Our report will need to accurately convey what we are witnessing." The delegation's next stop proved equally revealing. the massive aluminum production facilities of Alcoa in Tennessee. Here, enormous hydroelectric dams powered smelters that operated continuously, producing more aluminum in a month than Japan could manufacture in a year. The power generation alone was staggering, with single dams producing more electricity than was available in entire Japanese prefectures. Dr. Tanaka was particularly struck by the quality and quantity of alloys being produced. Their aluminum production benefits from both abundant domestic bauxite sources and nearly unlimited electrical power, he noted in his journal. The metallurgical quality exceeds our best efforts, while being produced in quantities we cannot comprehend. The Tennessee Valley Authority projects represented another dimension of American industrial might, government-directed infrastructure development on a continental scale. The delegation was shown how these massive public works projects not only provided electricity for aluminum production, but also controlled flooding, improved transportation through inland waterways, and brought electrical power to previously undeveloped regions. These dams were primarily built before the war, explained their guide, Robert Phillips, a senior engineer with the TVA. They represent long-term investment in our industrial capacity, investments now paying extraordinary dividends for our war effort. Kenji Watanabe, the petroleum chemist, was most affected by their next visit, the massive oil refining and synthetic rubber complexes near Houston, Texas. Having specialized in Japan's efforts to produce synthetic fuels from limited resources, he immediately grasped the hopeless disparity. Their standard oil facility alone processes more petroleum in a day than all of Japan's refineries combined, he whispered to Professor Yoshida as they toured the sprawling complex. And the quality of their aviation fuel, 100-octane produced in essentially unlimited quantities, gives their aircraft performance advantages we cannot match. The rubber situation proved even more sobering. Japan had gone to war partially to secure access to natural rubber plantations in Southeast Asia, a critical resource for military vehicles, aircraft, and naval vessels. Yet here in Texas, the delegation witnessed enormous synthetic rubber plants using petroleum feedstocks to produce material of equal or superior quality to natural rubber. We began this synthetic rubber program only after hostilities commenced, explained Dr. Eleanor Williams, a research chemist. Within 18 months, we've eliminated almost 90% of our dependence on natural rubber. By next year, we project complete self-sufficiency, with production exceeding 300,000 tons annually. Watanabe knew that Japan's entire rubber consumption before the war had been approximately 40,000 tons annually, with synthetic production capabilities still in early research phases. The most profound revelations, however, came during their visit to the Carnegie Steelworks in Pittsburgh. The immensity of the operation defied description, blast furnaces operating continuously, producing steel in quantities that the Japanese experts could scarcely believe. Our current production exceeds 80 million tons annually, noted William Stevens, the facility director. That represents an increase of approximately 60% from pre-war levels. Next year, we anticipate exceeding 100 million tons. Colonel Nakamura, scribbling calculations in his notebook, realized with growing horror that this single American industry produced more steel than Japan, Germany, and Italy combined. The implications for shipbuilding, armaments, and vehicle production were overwhelming. Equally impressive was the level of mechanization. Enormous overhead cranes moved massive ladles of molten steel with precision. Hydraulic systems controlled the flow of materials. Complex electrical systems monitored temperatures and compositions. The labor efficiency surpassed anything in Japan's industrial experience. Most of our processes are now automated, Stevens explained proudly. A steelworker today produces 4 times the tonnage compared to 20 years ago, with fewer injuries and more consistent quality. Stevens then revealed something that particularly struck the Japanese experts. Many of our most innovative improvements have come from the workers themselves. We maintain a formal suggestion program that rewards shop floor employees for identifying efficiency improvements. This collaborative approach contrasted sharply with the rigid hierarchies of Japanese industry, where improvements typically came from engineers or managers rather than workers. The cultural implications were not lost on Professor Yoshida, who had studied organizational systems extensively. That evening, the delegation attended a formal dinner with representatives from the American industrial sector. The setting provided an opportunity for more candid conversation about the philosophy underlying American production methods. Henry Kaiser, the industrialist whose shipyards had revolutionized maritime construction, explained his approach. The traditional shipbuilding wisdom held that constructing a Liberty ship required at least 200 days. We analyzed the process, broke it down into standardized components, employed prefabrication techniques, and introduced welding instead of riveting. The result? Our Richmond shipyard completed the SS Robert E. Peary in 4 days, 15 hours, and 29 minutes from keel laying to launch. Kaiser continued, warming to his subject. The secret isn't working harder, it's working smarter. We apply scientific management principles to eliminate inefficiencies. We standardize components so they can be mass-produced. We develop specialized tools for specific tasks, and perhaps most importantly, we recognize that the frontline worker often has the best insights into improving the process. Throughout the dinner, the Japanese delegation was struck by another aspect of American industry, the collaboration between potential competitors. Companies that had been fierce rivals in peacetime now shared innovations, coordinated production, and even exchanged workers to meet national objectives. Before the war, Ford and General Motors would never have shared manufacturing techniques, explained Charles Wilson, president of General Motors. Today, we regularly exchange information about production methods, materials conservation, and quality control. The result has been a dramatic improvement in efficiency across our entire industrial base. This concept of competitive cooperation represented another advantage that transcended mere production numbers. The American system seemed to harness both the innovation of capitalism and the coordination of centralized planning simultaneously. As the tour continued over subsequent weeks, the delegation visited aircraft engine plants, shipyards, tank factories, and electronics manufacturing facilities. Everywhere they observed the same patterns: standardization, mechanization, statistical quality control, and production volumes that dwarfed Japan's capabilities. At the Douglas Aircraft Plant in Santa Monica, they witnessed the production of transport aircraft that would form the logistical backbone of Allied operations. "We complete one C-47 transport every 90 minutes, explained the plant manager. Each can carry 3.5 tons of cargo over 1,500 miles. We'll produce over 10,000 this year alone. The logistics implications were immediately apparent to Colonel Nakamura. Such transport capacity would allow American forces to move troops, equipment, and supplies throughout the Pacific Theater with unprecedented speed and flexibility. Japan's limited maritime shipping, increasingly vulnerable to submarine attacks, could not possibly compete with this aerial transportation network. The electronic and communication equipment factories presented another revelation. At Western Electric's massive facility, the delegation observed the production of radar systems, radio equipment, and complex targeting devices in quantities suggesting that even basic infantry units would have access to technology reserved for elite Japanese formations. Every American bomber contains more electronic equipment than an entire Japanese infantry division, Nakamura noted grimly in his journal. Their soldiers operate at night and in poor weather conditions with effectiveness we cannot match. Perhaps most disturbing was the apparent ease with which American industry adapted to changing military requirements. When informed that a particular aircraft component was proving vulnerable in combat conditions, factories could retool production lines and implement improvements within weeks, a flexibility that Japan's more rigid manufacturing systems could not approach. As their tour neared completion, the delegation was invited to observe one final facility, a massive food processing and packaging operation supplying American military forces. Here, they witnessed the production of K-rations and other specialized combat provisions, designed to provide balanced nutrition while remaining lightweight and durable in field conditions. American fighting personnel received daily rations exceeding 4,000 calories, including protein sources, vitamin-fortified components, and even desserts and coffee, noted their guide Sarah Jenkins, a nutritionist who had helped develop the system. Each ration includes cigarettes and chewing gum for morale purposes. The contrast with Japanese military provisions, increasingly limited as the war progressed, was stark. Colonel Nakamura knew that Japanese combat units were already experiencing significant food shortages, with daily rations often below 1,500 calories and lacking essential nutrients. This comprehensive industrial tour complete, the delegation prepared their confidential report during the return journey. The document they produced was extraordinary in its detail and devastating in its conclusions. Professor Yoshida authored the introduction, which stated plainly, "Based on observed American production capacity, resource availability, and manufacturing efficiency, we must conclude that Japan's current war-making capacity represents less than 10% of our adversaries' capabilities. This disparity is not temporary, but structural, and the gap is widening rather than narrowing as American production continues to accelerate." The report proceeded with specific comparisons across critical categories. Aircraft production. American monthly aircraft production currently exceeds 8,000 units across all categories and is projected to reach 10,000 units by mid-1944. Japan's maximum production capacity under optimal conditions cannot exceed 1,200 aircraft monthly, with actual production declining due to material shortages and strategic bombing. Naval construction. American shipyards are currently launching warships, transports, and landing craft at a rate approximately 8 times greater than Japan's maximum capacity. A single American shipyard typically exceeds the production of all Japanese maritime construction facilities combined. Their Liberty ship program alone has produced more cargo tonnage in 18 months than Japan's entire pre-war merchant fleet. Armored vehicles. American tank production exceeds 3,000 units monthly, with continuous quality improvements. Japan's monthly production of approximately 50 units represents less than 2% of American capacity. Steel and aluminum. American annual steel production of 80 million tons dwarfs Japan's capacity of 7 million tons. More critically, American production continues to increase, while Japanese output is declining due to resource limitations. Petroleum products. American petroleum production exceeds 1.5 billion barrels annually, compared to Japan's domestic production of approximately 4 million barrels. Their synthetic fuel programs have eliminated critical aviation fuel limitations. Electronics and communications. American production of radar systems, radio equipment, and electronic components exceeds Japan's capacity by a factor of at least 15 to 1. Providing American forces with overwhelming advantages in detection, coordination, and battlefield communication. The report's conclusion, drafted collectively by the delegation, presented an unvarnished assessment. The industrial disparity observed represents an insurmountable strategic advantage that cannot be neutralized by tactical developments, fighting spirit, or operational excellence. American production capacity alone, independent of other allied nations, assures that Japan will face ever-increasing material disadvantages as the conflict continues. The document included a recommendation that Japanese leadership pursue diplomatic alternatives while military position retains some favorable elements, a carefully phrased suggestion to seek peace terms before the full weight of American industrial might make any negotiating position impossible. Upon their return to Japan in early 1944, the delegation presented their findings to a select committee of military and government officials. The reception was chilling. Admiral Somu Toyoda, after reviewing the report, responded tersely. "Your assessment fails to account for the spiritual strength of the Japanese people and the fighting quality of our forces. Americans may produce more, but they lack the will to sustain casualties. Your report places excessive emphasis on material factors while ignoring the moral elements of warfare." General Hideki Tojo, then serving as Prime Minister, was more direct. "This document would damage national morale if circulated. I am ordering all copies secured and classified at the highest level." Professor Yoshida attempted to emphasize the mathematical certainty of their conclusions. "The production disparities we observed are not matters of opinion or interpretation," he insisted. "They represent physical realities that will inevitably shape the outcome of this conflict." His objections were dismissed, and the report was indeed classified and effectively buried. The 5 delegation members were separated and reassigned to positions where their knowledge could be contained. Professor Yoshida to a minor technical college, Dr. Tanaka to a provincial steel mill, Kenji Watanabe to a synthetic fuel research facility facing critical shortages, Colonel Nakamura to a distant administrative post, and Lieutenant Commander Yamamoto to a naval base that would later be obliterated in American bombing raids. The strategic implications of their suppressed report would be demonstrated repeatedly as the war continued. American material superiority manifested exactly as they had predicted, in an unending stream of aircraft, vessels, vehicles, and equipment that overwhelmed Japanese forces throughout the Pacific Theater. By late 1944, American shipyards had launched more than 5,000 vessels, including 74 aircraft carriers of various classifications. Japan had lost most of its merchant fleet to submarine attacks, facing critical shortages of fuel, ammunition, and basic supplies. American aircraft production had reached nearly 100,000 units annually, with Japanese air forces increasingly unable to contest control of the skies. In October 1944, during the Battle of Leyte Gulf, the material disparity became starkly apparent. The Japanese Navy, operating with fuel reserves so limited that some vessels embarked on one-way missions, encountered an American fleet possessing overwhelming numerical and technological advantages. The result was the effective destruction of Japanese naval power. As American strategic bombing of the Japanese home islands intensified in 1945, the industrial vulnerabilities identified in the delegation's report proved devastatingly accurate. Japanese war production collapsed under the combined pressures of material shortages, infrastructure damage, and the systematic targeting of manufacturing facilities. By June 1945, aircraft production had fallen below 300 units monthly, many of which could not operate due to fuel shortages. Tank and vehicle production had effectively ceased. Steel output had declined by 60% from its pre-war peak. The human dimensions of this industrial disparity were equally significant. American forces were increasingly well-equipped, well-fed, and supported by sophisticated logistics systems. Japanese forces faced chronic shortages of food, ammunition, medical supplies, and transportation. The moral and spiritual factors that Japanese leadership had emphasized proved insufficient against the relentless material advantages predicted in the delegation's report. In a cruel irony, several members of the original delegation witnessed the fulfillment of their predictions firsthand. Dr. Tanaka, working at the steel mill in northern Japan, observed production decline to less than 20% of capacity due to coal shortages and power disruptions. Kenji Watanabe, at the synthetic fuel facility, struggled with equipment breakdowns that could not be repaired due to a lack of replacement parts. Colonel Nakamura, reassigned to a home defense unit, received recruits with minimal training and equipment described in official documents as improvised. Professor Yoshida, from his position at the technical college, maintained a private journal documenting how the industrial disparities they had observed in America were manifesting in Japan's deteriorating war situation. His entries grew increasingly somber as 1945 progressed. March 10th, Tokyo experienced massive incendiary attacks last night. The industrial district where I once consulted is entirely destroyed. Our air defenses proved completely inadequate against their B-29 formations. The technological gap we observed in American aircraft has only widened. April 15th, students from the college are being mobilized for aircraft production. They receive 3 days of training before beginning work. In America, similar workers received 2 weeks of training and had the advantage of working on standardized designs with proper tooling. Here, materials are so inconsistent that each component requires individual fitting. June 20th, received word that Commander Yamamoto perished when his naval base was targeted last month. Of our delegation, he was the most traditionally minded. Yet after our American tour, even he recognized the fundamental disparity we faced. His final letter to me acknowledged that the spiritual qualities of our forces, however admirable, could not overcome the material realities we witnessed. Perhaps most poignantly, Professor Yoshida recorded a conversation with a former colleague who had gained access to the classified delegation report in his role with the Ministry of Industry. He told me that recent production figures almost exactly match our projections from 18 months ago, Yoshida wrote. The gap has widened precisely as we calculated it would. Had our recommendations been heeded when presented, how many lives might have been spared? The suppressed report finally received vindication from an unexpected source. In August 1945, following Japan's surrender, American occupation authorities requested information about Japanese industrial capacity and wartime production. The delegation's report, retrieved from classified archives, proved to be the most comprehensive document available. General Douglas MacArthur's economic advisers were struck by the accuracy of its projections and analysis. James Forrester, an economic planning specialist with the Occupation Administration, later wrote, "The Yoshida delegation report from 1944 provided remarkably precise estimates of production disparities and their strategic implications. Had Japanese leadership acted upon these findings, the conflict might have concluded much earlier." In the post-war reconstruction period, several surviving delegation members played significant roles in rebuilding Japan's industrial base, this time, ironically, with American assistance and applying many of the manufacturing principles they had observed during their wartime tour. Professor Yoshida, appointed as an advisor to the Ministry of International Trade and Industry, helped introduce statistical quality control methods and production efficiency techniques directly adapted from American models. Dr. Tanaka contributed to modernizing Japan's steel industry using continuous casting methods he had first witnessed in Pittsburgh. Kenji Watanabe applied his expertise to Japan's emerging petrochemical industry, implementing processes based on those he had observed in Texas. Their wartime observations, initially dismissed, ultimately helped transform Japan's industrial approach. The emphasis on standardization, quality control, worker input, and continuous improvement became foundational elements of Japan's post-war economic miracle. Companies like Toyota and Sony explicitly adapted manufacturing principles that the delegation had documented, eventually developing them further into systems that American industry would later study and emulate. In 1964, almost 2 decades after the conflict ended, Professor Yoshida, by then an elderly but respected industrial consultant, was invited to address a conference on international manufacturing standards in Detroit, not far from the Willow Run bomber plant he had visited under such different circumstances. In his address, without directly referencing his wartime experiences, he reflected on the transformative power of industrial capacity. Manufacturing excellence transcends mere production numbers. It represents a society's ability to organize complex systems, allocate resources efficiently, standardize procedures, and continuously improve processes. These capabilities determine success not only in conflicts between nations, but in the broader competition of human progress. The delegation's journey had come full circle. The industrial might they had witnessed with such concern during wartime had become the foundation for peaceful competition and shared prosperity. Their observations, once considered dangerously defeatist, were now recognized as prescient analysis of fundamental economic and organizational principles. The story of these 5 Japanese experts, confronted with overwhelming evidence of industrial disparity, yet unable to influence their nation's tragic path, serves as a powerful reminder that in modern conflicts, production capacity often proves more decisive than battlefield courage or tactical brilliance. The American manufacturing miracle they documented represented not merely superior resources, but a more effective system for organizing human endeavor and technological innovation. As Professor Yoshida noted in his final public appearance before his death in 1972, what we observed in American factories was not simply material abundance, but a different philosophy of production, one that emphasized standardization, efficiency, continuous improvement, and respect for the contributions of every worker. These principles transcend national boundaries and ideological differences. They represent universal truths about how human societies can most effectively transform resources into capabilities. The lessons of this industrial disparity remain relevant today, reminding us that national power rests not merely on natural resources or temporary technological advantages, but on the systematic organization of production, distribution, and innovation. The Japanese scientists who toured American factories in 1943 discovered this truth through direct observation. Their suppressed report accurately predicted the inevitable outcome of a contest between unequal industrial systems, a prediction confirmed at tremendous human cost over the subsequent 2 years. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.